So a moment ago I said that sometimes you're going to be given one big log and you're going to be asked to break that into lots of little logs, but I also said that sometimes you're going to be doing just the opposite. You're going to be given lots of little logs and you want to bring them together as one big log. That's in fact what example 4 is doing for us. So notice we have lots of little logs and we want to bring those together as just one big log. So, okay, let's check out example 4a. We have 2 log base 3 of u plus log base 3 of v. Now, in order to know how to start this problem, you're going to notice that I've given you a statement over on the right-hand side about the order of operations. Remember that the order of operations, you can use the phrase PEMDAS to remember that, or the phrase, please excuse my dear Aunt Sally. So either way, it tells you that you have to think about your exponents before you think about your multiplications and divisions. So when you look at the fact that we have a 2 hanging out in front of a logarithm, remember that property 7 says that anytime you have a 2 multiplied on the outside of a logarithm like this, you can bring it up as an exponent. So anytime I look at a problem like this and I see that there's a 2 out in front, I'm always going to do that as my first step because that's associated with exponents in the order of operations. So if I do that as my first step then, this is going to become log base 3 of u squared plus log base 3 of v. So now that I've done my exponents first, the next thing that I want to think about are any multiplications and divisions that are happening. Well, here I have a log of somebody plus a log of somebody. As long as the bases on those logs are the same, I know that I have a property that allows me to connect addition to multiplication. So yeah, I do have the same bases, 3 and 3. So because I have the same bases, I can go ahead and use property 5 here. And property 5 says that if you have a log of somebody plus the log of somebody, you can bring this together as one big log that involves multiplication. So this is going to be log base 3 of u squared times v. And there we have our final answer. Next off then, as you look at part B, once again, the first thing that I'm going to notice on this problem is that I have a number out in front of a logarithm. If I have a number out in front of a log, that's associated with an exponent idea. So I'm always going to start with that. So this is going to be log of x squared plus 3x plus 2 minus, and then bring this power of 2 up. And it's going to be log of x plus 1 quantity squared. Now that I've done my exponent, I can think about my multiplications and divisions. So I have log of somebody minus log of somebody. Notice that the bases are the same. That means that I can go ahead and use property 6. Log of somebody minus log of somebody is equivalent to a division. So one copy of the LOG for the division, and we get x squared plus 3x plus 2 divided by x plus 1 quantity squared. Now that we have this then, we still have old ideas running around as well. So notice that x squared plus 3x plus 2 as a polynomial is factorable. So if I factor that, this ends up being x plus 2 times x plus 1 in the numerator, and in the denominator I have x plus 1 quantity squared. Now, as I look at the numerator and the denominator, I now have a rational expression that has a common factor in the numerator and the denominator. I can cancel that common factor. So cancel one copy of the x plus 1 from the numerator and cancel one copy of the x plus 1 from the denominator. And what we are now down with then is log of x plus 2 in the numerator and one copy of that x plus 1 in the denominator. And there's our final answer. This is log of the division problem, x plus 2 divided by x plus 1.